The star Betelgeuse, not to be perplexed with the character from the movie, is, without uncertainty, a huge grand body. In the event that we were to exchange Betelgeuse with the Sun, it would extend past the orbit of Mars and even reach the asteroid belt. What's even more concerning is that the James Webb Telescope has produced a distressing new discovery about Betelgeuse. Neil deGrasse Tyson has a few words to say on the subject. Despite its proximity of 700 light-years to us, Betelgeuse is the closest star to our solar system that experts anticipate will ultimately end its life in a cosmic explosion. Renowned astrophysicist Neil deGrasse Tyson has been vocal about Betelgeuse, pointing out its mind-boggling size and its striking reddish-orange color. He claims that it is one of the most unmistakable stars in the night sky and the closest star to the Sun that has a high probability of ending in a supernova. Like any star, Betelgeuse will eventually run out of fuel at its core. It will expand as it begins to shift, growing so extraordinarily large that it will engulf the orbits of Mercury and Venus and come extremely close to Earth. Imagine looking at the sky during twilight and seeing a portion of it illuminated by an unsettling Betelgeuse. Betelgeuse is known for its variability, with its brightness fluctuating over time. At its peak, Betelgeuse can shine incredibly brightly, almost matching the most brilliant stars above. Due to this variability, speculations have emerged about Betelgeuse nearing a supernova, suggesting a potentially frightening event for observers on Earth. However, this claim is uncertain. It is essential to understand that a star's brightness can change significantly. Comparing Betelgeuse with stars like Rigel and Betelgeuse further emphasizes this point. Rigel and Betelgeuse, while sometimes appearing similarly bright, can differ greatly in their luminosity. There is sharp interest in understanding the current state of this unusual star. Despite discussions about a possible explosion, researchers insist they are closely monitoring Betelgeuse's behavior to analyze any significant changes that might signal an approaching supernova. The speculation surrounding Betelgeuse's explosion has drawn attention due to its prominence in the night sky. However, astronomers and astrophysicists remind us that predicting such celestial events is not straightforward. While Betelgeuse's recent dimming has raised concerns, it is important to remember that stars, including Betelgeuse, undergo natural cycles of variation. Specialists continue to observe and investigate Betelgeuse using advanced astronomical instruments, including the James Webb Space Telescope. This cutting-edge telescope has significantly enhanced our ability to study distant stars and galaxies. Its observations of Betelgeuse provide valuable insights that help scientists understand the star's behavior and potential changes, adding more pieces to this cosmic puzzle. The process of a star reaching the end of its life and culminating in a supernova is a complex cosmic event. Betelgeuse's fluctuations have drawn attention and raised questions about a potential explosion. However, scientists approach such possibilities with caution. Studying Betelgeuse offers a unique opportunity to learn more about the life cycle of stars, their evolution, and their ultimate fate. The changing brightness of Betelgeuse results from various factors, including its size, temperature, and distance from Earth. This variation in luminosity is a result of the star's natural cycles and characteristics. Over a period of slightly more than 5 years, Betelgeuse has experienced significant fluctuations, presenting fascinating challenges and generating scientific interest in understanding these changes. In addition to Betelgeuse, this striking star is referred to by alternate names like Bellatrix, Betelgeuse, and Beetle, highlighting the variety of names used across different cultures. It is fascinating how a single celestial body can have multiple names and spellings, each derived from phonetic and historical contexts. The origins of the name Betelgeuse date back to the Arabic language. Scientists often debate the most appropriate spelling and pronunciation of this name, with Betelgeuse being the most widely accepted in scientific usage. Found in the Orion constellation, Betelgeuse shines as a red supergiant, attracting attention from a distance. Its approximate distance of 642.5 light-years from Earth adds to its status as one of the most extensively studied and captivating celestial objects visible in our night sky. Betelgeuse's distance is determined using various sources, including the Hipparcos astrometric satellite. This state-of-the-art instrument has provided essential insights into celestial measurements. However, measuring astronomical distances can be complex, and different data sources sometimes yield varying results. While the Hipparcos satellite estimates Betelgeuse to be around 430 light-years away, other measurements suggest a distance closer to 642.5 light-years. These discrepancies highlight the challenges of accurately determining stellar distances and the continuous refinement of astronomical methods. Studying the vast universe involves grappling with the enormous distances between celestial bodies. Betelgeuse, with its fascinating variability and immense size, provides a compelling case study for cosmologists and astrophysicists. Its unique characteristics and observable behavior significantly contribute to our understanding of stellar evolution and the broader universe. The fluctuations in Betelgeuse's brightness over time have prompted further research and observations. This red supergiant's dynamic nature presents an incredible opportunity to comprehend how such massive stars evolve and the intricacies of their behavior. Astrophysicists and cosmologists have employed various instruments and techniques to monitor Betelgeuse, aiming to unravel the underlying causes of its variability and its potential implications for the future. This particular period of transition has sparked increased interest in the star, leading to in-depth research and discussions within the scientific community. Despite speculation about a possible supernova event, Betelgeuse's ongoing dimming and subsequent brightening generate more questions than answers. It is crucial to exercise caution in making predictions, as a star's brightness naturally fluctuates and does not necessarily indicate an imminent explosion. The complex study of celestial bodies requires considering various factors such as size, temperature, and distance. Betelgeuse continues to be a significant astronomical object, offering valuable insights into the behavior and life cycles of massive stars. Ongoing observations and advancements in technology continue to shed light on the mysterious nature of Betelgeuse, contributing to a greater understanding of the universe. Betelgeuse, also known as Alpha Orionis, stands out as one of the most remarkable and captivating stars in the Orion constellation. Its dramatic variability in apparent magnitude, ranging from 0 to 1.6, makes it a prominent variable star. Although Rigel is sometimes considered brighter, Betelgeuse holds the designation of Alpha Orionis. Occasionally, fluctuations in brightness cause it to appear more luminous than it actually is, adding to its mystique. Alpha Orionis and Beta Orionis were assigned to Bug Guju and Riel, respectively, in the Uranometria of Jan Bayer, published in 1603. This arrangement helped cosmologists and stargazers recognize and differentiate between stars in the Orion heavenly body. Bug Guju, similar to many other stars, exists as a lone star, not part of a larger heavenly group. It lives in a region without star-forming activity. Its classification as a star on the rise distinguishes it by displaying its trajectory and distance traveled through space. This titanic divine object boasts a radius generally multiple times bigger than the Sun and a mass multiple times greater in importance than our solar system star. With an incredible radiance of approximately 126,000 suns, Bug Guju's splendor continues to be significant even at a distance of 548 light-years from Earth. Notwithstanding its extensive distance, Bug Guju presents an interesting contrast to our Sun. The star's surface temperature, around 3,600 Kelvin, is strikingly cooler than the Sun's 5,778 Kelvin. Regardless of its colossal size, this temperature discrepancy contributes to its particular red supergiant appearance and serves as a significant factor influencing its brightness and observable qualities. In regards to age, Bug Guju, at around 10 million years old, is relatively young compared to our Sun, which boasts an age of about 4.6 billion years. Notwithstanding its youth in cosmic terms, Betelgeuse has already undergone stellar evolution, reaching a stage where it displays the characteristics of a maturing red supergiant. Because of its enormous size and its stage in the life cycle of a massive star, hypotheses about Betelgeuse possibly ending its life in a cosmic explosion event have arisen. Such an event, if it were to happen within a couple of hundred light-years from Earth, would undoubtedly have significant consequences for our planet. The plausibility of Betelgeuse going supernova has garnered attention due to the potential impact such an event could have on Earth. However, scientists stress the need for caution in anticipating such massive phenomena. While Betelgeuse's physical characteristics and behavior make it an interesting subject for study, the specifics of a potential cosmic explosion and its consequences for Earth remain uncertain. Grasping the life cycle and behaviors of stars like Betelgeuse helps space experts comprehend the universe's cycles. Observations of this red supergiant continue to enhance our understanding of stellar evolution and the grand cosmic events shaping our universe. Despite all the speculation about Betelgeuse going supernova, it hasn't occurred yet. Rather, the star has been changing from dim to bright in a pattern that suggests it is just undergoing normal variations. Betelgeuse may ultimately explode, but it appears unlikely to happen anytime soon. Located in the Orion constellation, marking the right shoulder of the Hunter, Betelgeuse is a conspicuous and easily recognizable feature in the night sky. Its unmistakable red hue further enhances its visibility. The star is carefully observed in the night sky, especially during the early months of each year, making it a popular focus for astronomers and sky watchers alike. To unravel the mystery of Betelgeuse's behavior, analysts have extensively analyzed data from various sources, including NASA's Hubble Space Telescope and different observatories. These observations have provided critical insights into the star's later stages. The results suggest that Betelgeuse underwent a massive surface mass ejection in 2009, resulting in the loss of a significant portion of its apparent surface. This behavior is noteworthy and exceptional in astronomical observations, as such a phenomenon has never before been seen in a star of Betelgeuse's size and visibility. Certainly, Betelgeuse, also known as Bug Juju, is a fascinating red supergiant star located in the constellation Orion. Its apparent brightness can vary significantly, making it one of the most well-known stars in the night sky. While often confused with characters from popular culture, its astronomical significance is profound. At around 700 light-years from Earth, Betelgeuse is classified as the closest star likely to end its life in a dramatic supernova explosion. Renowned astrophysicist Neil deGrasse Tyson has noted its immense size and distinct red-orange hue, which contribute to its visibility. The star's size is staggering. It is about 1,000 times larger than our Sun and can shine with a brightness equivalent to 126,000 suns at its highest point. Betelgeuse has undergone significant changes in brightness over the years, with variations that can be observed even by amateur astronomers. As a variable star, its brightness can fluctuate from 0 to 6 magnitudes. This variability has sparked interest in understanding its life cycle and behavior, particularly because it is currently in a stage that demonstrates the characteristics of an aging star. The star has been extensively studied using advanced telescopes, such as the James Webb Space Telescope and the Hubble Space Telescope. These observations have provided insights into its behavior, revealing that it underwent a massive surface mass ejection in 2009, losing a considerable portion of its visible surface. Despite its potential to explode in a supernova, researchers warn against jumping to conclusions. The cyclical nature of stellar behavior means that normal variations in brightness don't necessarily indicate an imminent explosion. Instead, Betelgeuse may simply be undergoing a typical phase of its life cycle. Interestingly, Betelgeuse has various names across cultures, reflecting its historical significance in astronomy. The name is derived from the Arabic Ibt al-Jawza, meaning the giant's shoulder. This naming history highlights the way cultures across the world have observed and documented celestial bodies over centuries. Despite being relatively young at around 10 million years old compared to our Sun's 4.6 billion years, Betelgeuse has already passed through considerable stages of stellar evolution. It resides in an empty region of space, devoid of star-forming activity. Classified as a runaway star due to its trajectory, its temperature, about 3,600 Kelvin, is cooler than the Sun's 5,778 Kelvin, contributing to its distinctive red appearance. This difference in temperature is critical in understanding stellar evolution, especially as Betelgeuse continues to grow and consume its nuclear fuel. Astronomers continue to study and monitor Betelgeuse closely to better understand its life cycle and the implications of its eventual demise. While its variability and size present intriguing questions, they also remind us of the complexities of celestial phenomena and the need for caution when interpreting stellar behavior. The ongoing study of Betelgeuse not only enhances our knowledge of this particular star, but also contributes to a broader understanding of the life cycles of massive stars throughout the universe.